Hello, everybody. Uh, Welcome to this session. The objective of this session is to reply to these questions. Can we rely on natural ocean processes for climate mitigation? To respond to this question, we have 6 speakers today with presentations covering different aspects of blue carbon and nature-based solutions. To organize this satellite activity, the Environmental Economic section of the Monaco Scientific Center is working with Foundation Mary to propose a multidisciplinary international experts panel. In fact, this started with the 5th international workshop about bridging the gap between ocean acidification impacts and economic valuation that was held in Monaco on October 2021. This workshop, organized by the Scientific Center of Monaco, was truly interdisciplinary in character, involving sciences such as biology, chemistry, economics, law, and emphasizes the need to integrate the different disciplines, sectors, and biological processes in the management, business, and law practices, where there are weak and strong economic interests in the different regime zones at sea. The conclusions of the workshop highlights the nature-based solution as possible options to mitigate climate change or adapt to its negative effects. The participants considered the blue carbon and other marine biological processes as a solution to the ecological and socioeconomic impact of climate-related changes in the ocean. The first speaker is Lisa Levin. Lisa Levin is a distinguished professor of biological oceanography at the Scripps Institution of Oceanography at University of California in San Diego. She's passionate about the deep sea and researches the ecology of different ecosystems on deep continental margins, their vulnerability to climate change and to human resource extraction. She's an active contributor to IPCC assessments and reports and serves as scientific co-lead for both the Deep Sea Stewardship Initiative and the Deep Ocean Observing Strategy. Lisa could not be here today with us, but she sent me her video she recorded. So I will share it with you. I will share. I don't know. I think it's not. Sorry, I'm trying to share my screen. Just, yeah.
Hello, everyone. I would like to focus today on carbon in the open ocean and the deep sea. Most of the ocean, in fact, occurs beyond the coastal zone and in deep water and is the open ocean. These waters and their life play key roles in fixing, transporting, and sequestering excess carbon from the atmosphere. This happens through the biological pump, which removes carbon from the air through photosynthesis by phytoplankton, which can then form aggregates of detritus that sink into deep water or can be eaten by zooplankton and fish. And they often migrate vertically into the twilight zone. They defecate, they die, they sink, they're eaten by others that move that carbon into deep water where it is sequestered for long periods of time. Diagrams like this often leave out the fact that there's a large amount of carbon and biomass in fish and whales and in macroalgae that also sink into the deep ocean. There have been recently proposals to mitigate excess carbon through iron fertilization, basically through enhancement of the biological pump by adding iron to surface waters, by cultivating macroalgae in the surface and sinking it, or through artificial upwelling that also stimulates production, but very little known about the effectiveness or the impacts on the deep sea. What we do know through models is that to sequester carbon for hundreds of years using these methods, it has to be placed either very deep or in certain parts of the ocean. For example, the biological pump is most effective in the Pacific Ocean or in the Northern Indian or Southern Oceans if we want to sequester carbon for more than 100 years. If we inject carbon directly, either CO2 or perhaps sinking macroalgae, we have also to put the carbon thousands of meters down, and again, preferably into the Pacific, Indian, or Southern Oceans. We know that the important climate mitigation roles played by the open ocean can also limit the biological pump. Massive uptakes of heat are causing reduced solubility and increased stratification that lead to ocean deoxygenation and shoaling of oxygen minimum zones. This causes an upward habitat compression of very large fish and our vertical migrators, again, limiting the biological pump. The stratification also leads to declines in productivity at the surface with less export of carbon to deep water, and uptake of CO2 directly into the ocean waters leads to ocean acidification that reduces the calcification of our surface planktons, causing lower gravitational sinking and less export of carbon as well. So the biological pump can remove carbon, but our mitigation can inhibit that those pump activities. We also can ask where in diagrams like this as the bottom. We now know that our deep sea floor is not homogeneous sediment, but consists of many different ecosystems that provide important carbon services. These include in the deep pelagic, the vertical transport of carbon. It includes high rates of carbon sequestration on continental margins like oxygen minimum zones and in canyons and fjords. The vast abyssal plains store and sequester huge amounts of carbon. We have sequestration in biomass through massive animal abundances on seamounts and in inorganic carbon on coral and sponge reefs and at methane seeps where there's carbonate. We also have animals removing and filtering carbon emerging from the seafloor. And we have carbon services from our hydrothermal vents, which actually fertilize the ocean, adding iron. Many of these carbon services are in fact in jeopardy through industrialization of the deep ocean that can limit both carbon sequestration or cause release of carbon from the seabed, things like activities like mining the seabed or trawling the seafloor. Contamination can inhibit carbon sequestration, and newly proposed mesopelagic fisheries may reduce the carbon export in the water column as well. To combat this, we need deep blue carbon conservation. We need to go into this mode with climate smart fisheries management, both in the water column and on the seafloor. We need climate smart spatial planning in international and national waters. We need to build climate considerations into all of our activities, mining, oil and gas extraction, which we should not be doing, and fishing. So we're left with many choices, whether we want to destroy and degrade and possibly release carbon from the open ocean and deep sea, how we need to think hard about how we can maintain and protect the carbon services provided and consider whether we might restore, create, and build up our carbon stocks and carbon sequestration processes. And with that, I thank you.
Okay. I will stop to share. Oh, is it okay? Okay. Right. Now the next speaker is Jason Hall-Spencer, and Jason Hall-Spencer is professor of marine biology at the University of Plymouth in UK and Tsukuba in Japan. His group conducts applied research to provide policymakers with the scientific information needed to best manage the marine environment. This includes research into the effects of climate change and ocean acidification on algae and seagrasses to inform policy around blue carbon and the UN Sustainable Development Goals. He enjoys collaborating with other disciplines to help ensure that marine scientific research has societal relevance and impact. He has a PhD in seaweed biology and is currently working on the effects of marine heat waves, acidification, and increased storminess in Japan and the Azores, as well as the lionfish invasion in the Mediterranean. Jason is going to tell us about the use and abuse of nature-based solutions. Jason, the floor is yours.
Thanks, Natalie. Can I just check that everyone can see my screen? Yeah, thanks. Hi, Ralph. Okay, so this is a nice cartoon showing you that we've got only one ocean that we share on this planet. It's all connected together. And there's a campaign at the moment to drop the S, stop calling these ocean basins separate oceans, because they are in fact so interconnected that what we do to harm one area can cause problems in another. And a key example of that, of course, is ocean warming. So if we're warming the entire surface ocean, that's causing the biogeography of the ocean to change, and it's killing coral reefs. It's also causing deoxygenation, so less oxygen in the water, sea level rise, of course, extreme weather events, and coral reef loss. And so these are things that are making the ocean less safe. And I see that the theme of today's talks from all over the world is about a safer ocean. And it's clear there's things we can do to stop making the ocean more dangerous for ourselves and its inhabitants and start making it safer. So just a bit about me. I'm a professor at the University of Plymouth and also at the University of Tsukuba in Japan. So I'm UK and Japan based. Okay, now Lisa Levin, the previous speaker, and myself were involved in this recent World Ocean Assessment that was carried out by the United Nations. And here's a figure from that report, which makes it clear that, yes, the ocean is getting more dangerous for people. Carbon dioxide emissions are causing the ocean to start to kill people. And so clearly there are things going on that make the ocean less safe for people. So in Japan, where I'm working, for example, I got very, very scared one time because there was a super typhoon. We evacuated the marine station where I work and went to Tokyo, which was much safer because it had very good drainage systems. But if you look at all of these cartoons, there's cyclones, droughts, marine heat waves, sea flooding, etc., that are clearly all reasons why the ocean's becoming less safe. So I recommend that report to you, although it's not been widely disseminated. It's by the United Nations and it's freely available online. Okay, so moving over to Japan, where they're getting these supercharged typhoons now. That happens because this warm current sweeps up from the Philippines past Taiwan and across to Japan and brings with it heat and moisture. And that heat and moisture is causing much stronger typhoons and typhoons hitting land further north than they did in the past. And the warming of the sea is causing the kelp forests in the northern parts of Japan to die back. And it's also causing the coral reefs in the southern parts of Japan to die off as well. And that has knock-on effects to the ecosystem services that the ocean can provide the people of Japan. Now, I go to places that have got futuristic conditions. And this is one example. This is an area where there's carbon dioxide bubbling out of the seabed near a volcano. And this helps us work out at what levels of carbon dioxide are safe for humanity and the organisms that provide us with food. And actually, these natural gradients allow us to see the benefits that we accrue from meeting the Sustainable Development Goals of the United Nations, the Convention on Biological Diversity, and the Paris Agreement. It lets us calibrate the benefits that we get from reducing carbon dioxide emissions and looking after the biodiversity in our seas. And you can see using these systems what economic benefits there are and how it helps make people safer. So this is a little video, a baited underwater video, showing you the habitats and the fish in an area with high temperature and high CO2 in Japan. And basically, apart from the fish fighting each other, which obviously takes your attention, you can see in the background very low fish biodiversity, a very simplified habitat, and a damaged ecosystem. Now, if you contrast that to this area, which has got normal levels of carbon dioxide and hasn't been heated, then you can see that there are all sorts of things that benefit humanity. You get a more complicated set of habitats there. So in the background, there's various types of seaweeds and corals. And you've therefore got a higher diversity of fish and intact ecosystem services. So this is the future we want. And we'll get there by adhering to those agreements, those international targets and agreements. Now, I presented a version of this talk at the COP26 meeting in Glasgow, which was my first climate summit meeting. And I was astounded that the main group of people there, the main and largest group of delegates, were from the fossil fuel industry, which is clearly a problem when it comes to negotiating massive reductions in fossil fuel use. Now, moving on to the main topic of this talk is about the coastal blue carbon. So as opposed to Natalie's talk, which is about the offshore and deep sea blue carbon, this is about the best well-known blue carbon reserves we have. So salt marshes, seagrass beds and mangroves are the best understood marine ecosystems for adapting to sea level rise through flood defense and through mitigating the rising CO2 because they actually absorb and store carbon dioxide in the soils beneath them. And this is a place quite near to where I am in Plymouth, where salt marsh has been restored because the people who live there wanted it to help in their flood defences. Another habitat that I mentioned is the seagrass beds. They've actually declined by 90% in UK waters, but there are now efforts underway to regenerate them. It's not working very well in the UK at the moment, to be honest. We've got problems with germination success, but in the USA, they've demonstrated that planting a 2 kilometre square area quickly becomes an area with 36 kilometres squared of this fantastic super habitat for taking up carbon from the atmosphere. Now, at the meeting that Natalie mentioned in Monaco, we met with economists and lawyers and discussed what perhaps was the worst example of blue carbon nature-based solutions gone wrong. And this is what we came up with, the fact that mangroves, over the lifetimes of the students I teach, have been cut down and destroyed since the year 2000. 60% have been destroyed. And this is the worst case scenario we could find. It's a bit horrific, really. This is Nigeria, which has got the biggest mangroves of all of the African countries combined. It's got more in Nigeria than anywhere else in Africa. And Shell has actually caused 200 major oil spills. And by major, I mean 1.5 million tons of crude spilling into the mangrove forests of Nigeria. It makes an awful mess, as you can see in this creek. And horrifically, life expectancy of the people who live in these rural areas has declined by 14 years in just 2 generations. And if that wasn't bad enough, which is obviously the human impact is terrible, what we've done is turn mangrove systems that actually take CO2 out of the atmosphere and turn them into damaged habitats that emit CO2, methane and nitrous oxides. They're actually emitting climate warming gases. Now, the blue carbon concept in coastal waters has moved on from salt marsh, seagrass and mangrove to include other types of seabed habitat. This is quite new thinking, but for example, on the UK EEZ, we've got an awful lot of particulate organic carbon stored in some areas of sediment. So the areas of sediment that are muddy, predominantly, have got quite a lot of carbon in, and actually more carbon than the salt marsh, seagrass, and mangrove areas combined, because the area of the continental shelf is so vast. Now, here's one of my favorite habitats. So I hope I've got time to talk about it briefly. It's called Merle, and it's a seabed deposit that's calcareous, and it's home to these animals, which are called scallops, which are fantastic to eat. You catch them using dredges. So here's a dredge with the teeth that rake the seabed and bring up the scallops. And this is a little video showing what happens when you rake the seabed for these mollusks. And essentially, you can see this plume of carbon-rich sediment being stirred up and put back up into the water column. So instead of being a store for particulate organic carbon, this fishing activity liberates that carbon back into the water column. And that's a problem because these habitats are actually thousands of years old. Now, there's another campaign called 30 by 30, which is to get 30% of the ocean properly protected by the year 2030. Now, the UK has actually got a third of its exclusive economic zone protected on paper, but 95% of that is actually open to trawling and dredging. And unfortunately, the fines that are given out if people break the law don't match the damage that's caused. So just a couple of slides to finish here. The Paris Agreement clearly won't be met without urgent ocean action. And here's four of the key reasons, key points we need to work towards. So we need to redirect financial support away from activities that damage the ocean. So that includes, for example, overfishing, trawling, sewage, oil exploration and mining, which Lisa also said. We need to shield at least 30% of the ocean through fully or highly protected areas. A high seas treaty is needed for the area of the planet, the half of the planet that's beyond national jurisdiction. And we need to actively restore marine habitats to help recover marine life. So that's it from me. Thanks very much, Natalie.
Thank you, Jason, for this excellent presentation. And the next speaker is Lars. Lars Teman is a marine scientist interested in plankton, long-term variation and spatial patterns, a key component of the biological carbon pump. He works in the laboratory of oceanography in Villefranche-sur-Mer. He has co-published 80 research articles in peer-reviewed journals. He was awarded a research chair by the CNR Sorbonne to study the impact of global changes on pelagic ecosystems. From 2014 to 2016, he led the team Processus dans les écosystèmes pélagiques at LOVE, and became from 2017 to 2019 executive director of the Institut de la Mer de Villefranche-sur-Mer. From 2009 to 2016, he led the Villefranche quantitative imaging platform and contributed to the development of new imaging sensors for global observation. He is co-responsible of one of the two tracks of the Master of Science de la Mer at Sorbonne University, and the representative of Sorbonne University as the Imbursi Erasmus Mundus program. Lars is going to tell us about the impact of climate change, marine ecosystem, and carbon sequestration in the open ocean. Lars, the floor is yours.
Thank you very much, Natalie. Do you all hear me and do you see my slides?
Yes.
Yes? Okay.
Thank you.
So if I had known you would read my biography, I wouldn't have made it shorter. So thank you for listening, and I will try to show you what are the impact of climate change on marine ecosystems and also on the carbon sequestration, and both in the open ocean. I will be showing results that are coming from global modeling, because without the understanding on the ecology of the ocean and the use of those models, we are unable to answer to such large scales. And among the models that I will use results from those which are in the IPCC report. So who are the players in the open oceans? Well, the players, as shown by Lisa, are mostly autotrophic organisms that are very small, microscopic, less than 20 micron usually, so that's phytoplankton. Then you have multicellular first consumer of the primary production of the phytoplankton, which are the zooplankton. And then you have all the larger predators, which can be small fishes and also up to the whales. Those players are very important for the ocean because they do provide service. So among the services that I will introduce you today is the carbon sequestration. So phytoplankton, through the photosynthesis, fix the carbon dioxide from the atmosphere to the body, to the tissue of those organisms, and those are then eaten by the zooplankton, and the zooplankton is eaten by fish, and that's the food web. So all the carbon which is fixed by the phytoplankton in that transfer of biomass goes to the fishes. However, it's not very efficient. There are a lot of loss, and those loss are either the detritus produced by different kind of organisms, but also the dead bodies. And all those particles attracted by the gravity sink to the bottom of the ocean. And but not all what is fixed at the surface goes to the deep ocean, because on its way to the deep ocean, which can take up more than months, they are degraded by the bacteria and by other consumers that live in the deep sea and respire this carbon, which is then released again in the water column. And that is the reason, for example, for a very strong increase in the acidity in the midwater of the ocean. That's because of the respiration mediated by all those living organisms. Finally, at the end, there is a very small amount that reach to the deep ocean that if it's very deep, we usually says deeper than 1,000 meters, is sequestered for a very long time, which is at the scale of the centuries to the millennia. And then that's the biology, but then you have the physics of the ocean, and the physics of the ocean is transport. And the transport will move laterally organism and will also remix all the water columns, bringing back the carbon dioxide, but also all the nutrients to the life in the surface of the ocean. So who are those players? So if we look at what we call the biomass spectrum, that describe how much biomass you have through the size range of the living organism in the ocean that goes from the bacteria to the whale, then we can see that on average, there is more biomass in the small organism than in the large organism. The figure that you see here is the situation, is the current situation. In the current situation, you can see that there is, for example, a very strong drop of the marine mammals that are well below this kind of average slope that is given by this linear slope. So we can wonder if this size distribution, this biomass distribution has changed through time. This, oh yes, and before getting there, I wanted to add that this biomass is not evenly distributed in the ocean, but is distributing mostly according to the latitudes. You have more biomass in the higher latitudes than you are in the intertropics. But you do have some biomass in the Pacific and the Atlantic at the level of the equator, and that is because of upwelling in those areas. So if and finally, I would say that there is a strong latitudinal effect, but also you have specific places which are on the eastern boundaries of the oceans, where you have a strong upwelling that brings the nutrients to the surface, which allow the biomass to develop in those systems. And you have 4 major upwelling systems, which provide most of the fishes that we eat. So has this biomass changed through time? So here is a result of a model that is used by the IPCC that show in at 3 different time periods before the industrialization, presently, and in the future, the biomass of bacteria in gray, the biomass of phytoplankton in orange, the biomass of crustaceans in blue, biomass of fish in dark blue, of marine mammals in red, and in pink, the biomass of the human. And what you see is that there are groups which have declined, such as the crustaceans, the fishes, and the marine mammals. Groups that have not changed, such as bacteria and autotrophs, and then groups that have increased, that is us. So why did those groups decline? There are 2 reasons. One reason is the climatic change with warming that decrease primary productivity and make it less accessible to the predators. But you also have the fact that our human activity in fishing directly collect the biomass in the sea. That can be also modeled. And here I show you the proportion according to the size of the organism of objects that have, living organisms that have been disappearing due to climate change, and that is the pink, or the pink curve, and due to the fishing. And we can see that the fishing mostly concentrate on the larger organisms. So fishing pressure has a very strong importance in the open sea. If now I re-show you again this plot which I showed you earlier, which was the current situation, if you add up all the organisms which have disappeared because of fishing, that's all the shaded pink area, you can see that the biomass spectrum of the living organism has really changed due to our activity. And it's a change of more than 20% of the biomass. So now the carbon sequestration part. Carbon sequestration, as was presented by Lisa, is the way by which carbon dioxide is subtracted from the atmosphere in the living biomass of the ocean, and that the production, part of it, is attracted by gravity and sink to the bottom of the ocean. As you can see by the size of the arrow, the amount of carbon that is stored in the deep ocean is very small relative to the amount of carbon that was fixed at the surface, because most of it is respired already in the surface layer, but also in the deep layer. So can climate change, which affects the community composition, can it change the carbon sequestration? So to do so, first we have to look at, is there a relationship between where we have the biomass and where we have the exports of carbon? And so, for example, here you have the map of the carbon that is exported from the surface layer. And you can see that it really mimics the pattern of the biomass of the living organism in the ocean. Then we have to really understand that not only it's important to have a strong productivity at the surface, but it's also very important to have a very good transfer of that productivity to the deep ocean. So if you take these examples where you produce 1,000 by the primary production, then because of the respiration, only 100 of this is going deeper than roughly 100 meters, which is where you start not to have any more light. And then if you go deeper, roughly to 1,000 meters at the base of the twilight zone, you only have 10. So you have already reduced by 1% the total amount that was produced at the surface. But then at 1,000 meters, this carbon is only sequestered there for centuries. If you want to have a very long sequestration time, you need to go deeper to, let's say, 2,000 meters, where it will be sequestered for millenniums. And at the end, everything which will be fixed in the sediment is stored for the very long time. So we have to know what is this attenuation rate, or what is the transfer efficiency. To do so, it's very difficult to obtain such information because that's in the middle of the ocean, and it's technologically it's very hard. So here's a compilation of data that show you the decrease in the flux of the POC through depth, and that you can mimic it with a curve that is called the Martin curve, where you have the equation here, and the important parameter of the equation is this term B. The value of B on average is 0.8. And B will, depending on the value, it will affect the transfer efficiency. And B is there because B is for biology, because the consumers of this flux of carbons are living organisms, bacteria and plankton, and also necton, so fishes. And there, still by modeling, you can make a relationship between the amount of primary production, which is here, and the transfer efficiency. So the two important components, the strength of the production and the strength of the attenuation. And you can calculate for those couples of values what will be the amount, the concentration of carbon dioxide in the atmosphere. And you can see that depending to the value of P, for example, you can go, given a primary production of 10, with a value of B of 1.1, you have 240 ppm in the atmosphere. With a value of 0.7, you have 170 ppm in the atmosphere. So a very strong change. So it's very important to know what is the value of this transfer efficiency. Finally, that's the last slide for a conclusion. The take-home message is that with quite a high confidence, we can say a lot of things for the upper layers. Reduced new primary productions because of global warming. Change in diversity of the primary producers, but not the biomass. The big species are replaced by small species. We have a reduced biomass of zooplankton and large predators because it's harder to feed on smaller phytoplankton. And we have a reduced export from the surface layer. What we know, but with a lower confidence, is how much is sequestered. And that is because we have a lot of uncertainties in this transfer efficiency. But at the end, if we assume that this transfer efficiency doesn't change, but that the exports from the surface change, then we can calculate that in different scenarios, the strength of this carbon sequestration will decline through times. And here you have a simulation by under different scenario that it can decline between 27 and 43%, given compared to the current situation of the carbon sequestration. So I was also in Monaco last year in autumn, and we spoke about price of carbon. And in this paper, they do transform the loss of carbon sequestration into a monetary value. And they come with the point that if by climate change, the ocean doesn't fix or fix less carbon, that would be about between 170 and 3,000 billion dollars in abatement. And there are also costs which are associated to the adaptation. Thank you very much. That was my last slide.
Thank you, Lars, for your very good presentation. And now the next speaker is Sonia. Sonia is Executive Director of Mary Foundation, and I would like to thank Mary Foundation for this very good collaboration, because we are co-organizing this session, and it was a pleasure to work with Sonia and Patricia on this. Sonia Español Jimenez is Executive Director of Foundation Mary. Until 2021, she was the lead researcher of Foundation Mary Cetacean Area and the director of the Blue Boat Initiative. With a degree in marine science in University de Cadiz in Spain, a master's in renewable energies and a PhD in marine biology in Chile, she has specialized in marine mammals, mainly in the study of the edification, distribution, and behavior of whales through their sounds. The Mary Foundation leads the line of cetacean research with projects aimed at reducing the threat of collisions between ships and whales. Sonia, the floor is yours.
Thank you, Natalie. Can you see my PPT? Okay. Thank you very much. It's a pleasure to be here with you and all the rest of the speakers. Thank you very much for this. For a start, I want to remember you that we know that climate change is a reality and we need solutions urgently. In this sense, the challenge is limiting the more devastating impacts, avoiding the planet warming more than 1.5 degrees Celsius. However, we are far from this. Scientists estimate that we will need 1.6 Earth-like planets to maintain our actual lifestyle. For these reasons, it isn't enough to reduce the greenhouse gases. We also need to eliminate from the atmosphere. To do this, the nature-based solution could be a solution, reducing the impact of this climate crisis, decreasing the risk of disaster, and giving resilience for the communities. In this context, the ocean is one of the principal ecosystems. Oceans are drivers of the global economic growth, and in nature context, they are key because they absorb more than half of the anthropogenic carbon emissions. Oceans also regulate the planet's climate and provide at least half of the oxygen that the planet needs. So we need to stop to see the ocean as a source of raw materials and start including their ecosystem service in policy publics to not only have an effective conservation, but also a mitigation in this climate change. We need to recognize the ocean action is a climate action. There are different ecosystems in the ocean that can mitigate climate change. For example, whales. Whales are an umbrella species because the conservation and protection of these species indirectly affect the conservation and protection of other species within their ecosystems. This is because baleen whales are in every ocean. Baleen whales also are called ecosystem engineers because they participate in the ecosystem through different roles. For example, they are food for the predators. Also, they are the predators for fish or invertebrates. And in the most important role is that whales are fertilizer for the oceans, effect that we can call whale pump. This whale pump have to be relationship with the situation that the iron and nitrogen are limited in marine ecosystem, but they are essential for plant and animal life at all levels of the food chain. These elements need to be available at surface of the oceans where they can stimulate primary productivity through photosynthesis. Many baleen whales feed at depth, but defecate and urinate at the surface, transporting these limiting nutrients. This process helps to combat climate change and global warming, as carbon is absorbed and sequestered during photosynthesis. Baleen whales also transport nutrients when they migrate from highly productive feeding grounds to nutrient-poor breeding grounds. When they die, their bodies sink to the seafloor, where they create a mini ecosystem of life. More than 200 species can inhabit a single skeleton, contribution to marine biodiversity and ecosystem complexity. And after this, carbon is incorporated into marine sediments and will never come back to the atmosphere. Baleen whales store a great deal of carbon. A single whale can store 23 tons of CO2 in their body. We currently know that baleen whales are more than food, and the science valorizes their marine ecosystem as first, their contribution in the fishing, as about 115 billions. They apport in the tourism industry about $2 billion. They help in climate change mitigation with the capture carbon dioxide in their bodies and improving the phytoplankton productivity, which captures about 37 billion tons of CO2 per year. All of this represent an economic value of near $3 million for the population of blue whales in Chile, perhaps more, because we know that not everything can be evaluated. For example, whales have an incalculable value for the local community that lives with them because whales are part of their culture. But whales are under threat. Marine traffic is currently the main risk for whales because ship strikes and the underwater noise pollution. To help protect whales, we are developing the Blue Boat Initiative with the Ministry of the Environment of Chile. I can share with you a little video about this project.
For millions of years, whales have populated the waters from the Antarctic to the Arctic, sequestering 33 tons of CO2 over their lifetime. That's 1,500 times more than a tree. Their bodies absorb the CO2 so that it does not go back into the atmosphere, thus helping to produce one of the main gases causing global warming. As they swim, the whales also provide nutrients to the oceans. These nutrients are a source of microscopic life, such as plankton, which helps the oceans to produce 50% of the oxygen consumed by the planet. It also serves as food for other organisms, creating an endless chain that favors the entire marine ecosystem and human beings who benefit from fishing activities. The more whales, the more fish. However, whales are under threat. Between 2007 and 2019, over 1,200 whales died. This is why the Blue Boat Initiative was born. The Blue Boat Initiative will install and connect the first South American network of early warning acoustic buoys for whale protection. A network of intelligent buoys with a complex system of hydrophones, oceanographic sensors, and transmitters, which will begin to operate in the south of Chile. This is one of the main feeding and breeding areas for whales in the southern hemisphere, thanks to the great supply of food and shelter generated by the unique combination of fjords and the subantarctic and oceanic currents. The Blue Boat Initiative will begin in the interior sea of Chiloé, the Gulf of Ancud, and the Gulf of Corcovado, and then cover the entire migratory route of the whales. The satellite information sent by the buoys will allow vessels to be warned in real time about the presence of whales so that they can take measures to avoid hitting these valuable cetaceans. These buoys will also make it possible to collect vital data regarding the global warming of the oceans, thanks to the oceanographic sensors that will monitor the health of the oceans. The ocean is an essential part of the cycle of life, and we can help keep it healthy, multiplying and benefiting the whole world. Be part of this unprecedented Chilean initiative. Help us change the history of the ocean and the world.
Well, with this project, we want to contribute to the care of whales, avoiding the risk of collision with vessels. For this, we will install and connect the first early warning system for whale presence in South America. We will also analyze the ecosystem service of the ocean, starting with the reduction of carbon dioxide stocks in the atmosphere. We will be able to detect the presence of different whales in real time through their sounds and send an alert to the vessel to reduce the risk of collisions. Also, we will be monitoring different oceanographic variables to study the health of the ocean. This project involves the collaboration of national and international public and private institutions, as we need technology, science, society participation, and policy decisions to obtain an effective conservation of whales. We believe that climate policy must be associated with conservation efforts. You can find more about this project on our social medias. Thank you. Thank you, Natalie.
Thank you, Sonia. Very nice presentation. And the next speaker is Ralph Shami. Ralph Shami is currently Assistant Director and Chief of the Financial Policies Division in the Institute for Capacity Development of the International Monetary Fund. Between 2014 and 2020, he was in charge of developing the Capacity Development Program for economists at the IMF and member countries. Dr. Shami is an experienced specialist in macroeconomics on fragile states. He also developed various innovative researches on valuing nature-based solutions to climate change, focusing on large mammals, elephants and whales, for instance. Ralph is going to tell us about how to take the nature to the markets. Ralph, the floor is yours.
Thank you, Natalie, and thank you, Sonia. Thanks to both organizations for inviting me to be with a group of colleagues to talk about a very important subject. I am the least scientific among all of my colleagues here. I'm just a financial economist. So let me share my screen. Go. Okay, are you able to see the screen? Thank you. All right, so my job is to, this for some reason, it's tracking subtitles. Okay, so my job is to showcase how we can actually use markets to help protect the oceans and the stewards of the oceans, the local communities and indigenous population, and create what I believe to be a win-win model for nature and for humanity. So I'm going to start with the COP26, where finally it dawned on everybody that we're not only facing climate calamity, but we're also facing real risk to the natural capital, and natural capital includes the oceans, of course. And that's what my colleagues we've been talking about today. And both are due to the activity of humans. So if we hope to deal with these two risks that are occurring at the same time, we need to mitigate or change behavior, our own behavior. And so the question is, how are we going to do this? well, before you provide solutions, you have to understand how you arrived there. And we arrived at this calamity because our economic system acts as if economy is outside of nature, which allowed us to extract with impunity and pollute with impunity. And that we have, as we are finding out now, that is unsustainable behavior, has led to the climate calamity, which boomeranged back to us in terms of loss of the natural capital. So obviously, before we talk about solutions, the most important part is to realize that we are not outside of nature, that our economy and our societies live within nature. Nature is the home where we live. When nature grows, we grow. When nature is stressed, we all feel it. In the language of economics, that means nature is macrocritical. Now, to make the case that nature is incredibly important, as if we need to, but we still have to do it for some reason, prove that nature is critical to the economy, we've got to start somewhere. And my colleagues have been talking about the value of nature, in this case, the oceans, to humanity from a scientific perspective. So I'm not saying anything new here, so I'm going to go quickly through these slides. Sonia and colleagues have already talked about, and Lars, about the impact of the importance of phytoplankton. Science also tells us that these great whales contribute tremendously to the sequestration of carbon dioxide, be it directly on their body or indirectly through the fertilization of phyto. Science, if you want to just jump quickly to land, science, this is Fabio Berzaghi's work of 2019, shows that the elephants in the forest also, these are the cousins on land, also have to sequester carbon in the trees, in the forests of Africa. And science also tells us that salt marshes, as Jason was saying, salt marshes, seagrass, mangroves, also have to capture carbon, but they also provide other ecosystem services, such as their great defense, natural defense against flooding, and provide for greater fish stocks. So what really science is telling us is that biodiversity of a living nature, not of a dead nature, of a living nature is very important, okay? We can even now, now that the science has told us this, I'm a financial economist. Once I have that science, then I can turn around and say, well, how valuable is it in dollar terms? And as Sonia was showing, and Lars also hinted some numbers, we can value the economic services of a whale. Not all of the services, because not all of the services that the whale provide have a market so far. But if we just look at the carbon sequestration part, at the whale tourism, and then the impact on fishes, the lifetime earnings of a single whale is over $2 million, just from these three services. We can do the same with the elephants, but in this case, just looking at the carbon sequestration due to the work of these forest elephants, it's over $1.75 million. If we were to look at the carbon sequestration alone of seagrass, just carbon sequestration by seagrass, the value of their carbon sequestration is over $1.5 trillion. So nature is very valuable to us. Science tells us that. We, as financial people, can come around and basically translate that the benefits in science into the language of markets through converting them into dollars and cents. But in order for us to go beyond the valuation and the wow factor, wow, this is a big number, is in order for us to create markets around nature, we need to do a bit more. And the third pillar of this work is really the legal framework, meaning these assets, be it salt marshes, seagrass, fixed assets, or be it whales, elephants, sharks, who owns them? Who has the right to speak on their behalf? So the legal rights is very important. Of course, the valuation is there, but then once you establish this, we really need to bring in the monitoring part, which is what Sonia is talking about, and in terms of the Gulf of Corcovado, we need an enforcement. These two are very important here, enforcement and incentives. That's when really the markets can start to be effective in helping to protect the oceans and its inhabitants. So if you ask, where are these rights? Which countries have moved on with the implementation of rights? Well, guess what? Chile recently, in the draft of what would be the new constitution, there's something called Article 9 now, which endows nature with rights. So that's a move in the right direction. New Zealand is already there, conferring personhood on its rivers, which means a river in New Zealand has as much rights as you and me. Ecuador, also rights of nature is enshrined in the Constitution. Costa Rica conferred personhood on bees because realized the importance of bees to pollination and so forth. So these examples, I would expect that these examples are going to ratchet up very quickly as we move on in time. Once you do that, once you marry an asset with the legal framing, or what's called codification in the law, it becomes capital. In fact, it becomes financial capital, which ends up on the balance sheets of countries or whoever owns the natural asset. That's when the markets say, okay, that's a new class of assets. I can make a market around that. So I thought I would give you an example of how markets can actually help in concrete terms. Okay. So let's go back to the Blue Boat initiative that Sonia was talking about, which is an incredible feat. The installation, Sonia, showed you the video and talked about the installation of these monitors in the water to basically, in real time, they're telling you what kind of whale is at what depth, at what location, beams that information to a satellite, which sends it to a land center, and the land center sends a text to the ship saying, hey, watch out, there's a humpback in your way. So the vessel is informed of the whale's presence, and the vessel is supposed to take action to avoid collision. Now let's bring economics into this conversation. Here's what happens next. Changing course or slowing down involves cost. After all, the captain of the ship is saying, well, I'm on my way to the harbor. I need to deliver my whatever cargo I have. Will I slow down if there's a whale in my line of sight? Well, if I do, I may have to slow down or change direction. That's going to delay me, and that is costly. So then the captain must be thinking, what's the penalty if I end up hitting that whale? Well, currently the penalty is 0. Okay? Anywhere in the world, you hit a whale right now on a bow of a ship, despite marine protected areas, whatever you want to call it, there's no follow-up to that. So what do you think the ship's captain is going to do? Well, we all know, unfortunately, what the captain of the ship is going to do is just going to keep going through because he's late on delivering his products, even if he loves the whale itself. So, but since we are looking for a solution of how the markets can help, here's how the markets can help. First, by helping ourselves. What if the government were to announce a policy change? Basically saying, look, if you hit a whale in my water, let's suppose it's Chile, Sonia has a paper that basically shows that a blue whale is the value of a blue whale, just in carbon alone, mostly, is over $3 million. Well, let's take $2 million. If you hit the whale in my water, the penalty is going to be $2 million. Okay? Now, what the ship's captain is going to say, wait a minute. So if I hit a whale, I'm going to pay the government $2 million. Whereas if I'm late on delivery, I may pay something, but certainly $2 million far outweighs the penalty from delay. So most likely, the ship will slow down. So you got to start with the policy first. But it gets better. Because once you have this, you have the valuation and you have the legal action on the government side, the market suddenly say, wait a minute, this is a new asset class in the water. This maritime insurance comes in. Now we'll price the contract. We'll call up the ship's captain or the owner of the fleet, say, wait a minute, when I insured your ship, there was no asset in the water called whale that was worth $3 million. They had no value. And now if you hit it, I'm going to have to pay on your behalf. So what's going to happen is insurance contracts will change, will either be priced into the contract or maybe ships will not be insured. Whatever it is, it's going to affect the ships. So ships now will try to avoid hitting whales to avoid market penalties. So the ships here are not really only worried about the government basically penalizing them. They're worried about the insurance companies dropping them, or even the rating agencies saying, you're not as riskless as we thought you were. You may actually incur losses. So on the other hand, ships that do install, say, devices on the ships that will keep them away from the whales may be rewarded by a lower premium or better rating from the rating agencies. This is just an example to show you how markets reinforce the message of the policy change. And therefore, what you have You have the policy action with the market mechanism reinforcing the same message and thereby changing the behavior of the economic agent. But guess what? Markets can do more than that. This is from the sort of the risk side. But here's another way that markets can help. Guess what? Well, because climate change is here, there's a market for carbon offsets. And that market really came about in force due to the Paris Accord. Paris Accord and the commitments to go carbon zero, carbon neutral, carbon negative created insatiable demand for carbon offsets by countries and firms. The issue has always been, how are you going to meet that demand? There's a high-tech route, which Greta, I'm going to steal the verse from Greta. She says this is lots of blah, blah, blah. And then there is the Earth-tech approach, which I'm going to steal that from a colleague of mine. She's the one who coined Earth-tech approach, and basically nature. Nature is there and can help us to sequester carbon, as colleagues were talking about the ocean ability to sequester carbon. There is even a price. If you go today, you Google right now, the price of carbon on the European exchange, right before the Ukraine debacle, the price had reached 110, 115. It dropped to 65, and now it's back to 78. So there's already a price. So how can this help us in our quest to protect the oceans? Well, guess what? Here's how you can do it. We can actually sell the carbon offsets in the ocean. Let's say we can ascertain the ownership of the whales in the Gulf of Corcovado. They're in the Chilean waters. Well, who would be interested in buying those carbon offsets? Well, could be households, could be firms, could be financial firms. They would pay money to basically get in return the offsets. And the money would go to, who is providing the offsets? In this case, you have whales, you may have elephants, you may have seagrass, salt marshes, mangroves. These are the various natural assets that can provide the offsets. We can even use blockchain technology to make sure that we are very careful as who owns what, where the money is going, and so forth. But most importantly is the money would go to look after the whales in perpetuity and to look after the stewards of nature in perpetuity. That would be the local and indigenous population. Okay, so this I wanted to show you who benefits from this. If we were to sell the carbon offsets, be it of whales or mangroves or seagrass, what have you, nature would first benefit, because you can only sell the offsets if nature is alive and well and doing well. So that increases the resilience of nature. Who else would benefit from it? Well, whoever owns the natural capital. If we're talking about whales, or we're talking about mangrove, seagrass, salt marshes, the government of that country would benefit directly, indirectly through the expansion of the tax base, and by reorienting its spending. So the fiscal stance of the government also is enhanced. Local communities will actually benefit because they're the true stewards of nature through sustainable income, meaningful employment. That will enhance resilience in the local indigenous people. What do the buyers of the offsets, carbon offsets, get? Well, they get to offset their carbon, but they get a lot more. They get to meet their ESG, they get to meet the SDG, Sustainable Development Goals, 1, 8, 10, 13, 14, 15. And they get to invest in nature. After all, that's the only solution out of this predicament, is to bring people back to nature and use nature to mitigate climate change. So when you put it all together, if you ask me, how do we go about doing this? Well, the first thing you got to do is from the supply side, supply the carbon offsets. In this case, it doesn't have to be carbon offsets, could be biodiversity offsets, ecosystem services, which whatever it is, is services of nature. First thing is the country got to do is undertake a scientific assessment. My colleagues here are scientists. They're the ones who would do this, which is, what do you have in your country? What kind of, how many whales, how many elephants, how many trees, how many mangroves, salt marshes, etc. And then after that, people like me would come around and basically do the financial valuation. But then you still need the legal action, as I showed you. You still need the government to basically, to use an American expression, put its money where its mouth is, and basically say, these assets are protected with a penalty. Once you do that, the asset becomes natural capital. It comes on the balance sheet of the country. It changes everything. Once that is done, then the markets here on the right-hand side basically take note of this and make a market around the natural assets. But it's very important here. One thing to keep in mind is this thing in the middle column, is when we talk about markets for nature, there are two key principles we need to keep in mind. One is nature is never sold. The assets themselves are retained, the ownership of those assets are retained by the indigenous population or the government of that country. What you're really selling are the services of these assets. And the money comes in to look after the nature in perpetuity. That's the first principle. And of course, if you cannot do that without looking after the local and indigenous population who are the true stewards of nature. Thank you. I'll stop here.
Thank you, Ralph, for your very good presentation. I think it was interesting to have also this economic and financial aspect in our panel. And now the last panelist is going to tell us more about the legal aspect. Eric Van Doorn worked in the legal office of the International Tribunal of the Law of the Sea in Hamburg before he moved to the Kiel University for his PhD in International Fisheries Law. In his current research, Eric focuses on mineral and living resources, but the legal implications of marine spatial planning and the legal aspect of marine uptake of carbon dioxide. He has been a member of the SOLAS Scientific Steering Committee since 2017. And Eric is going to present about the law and governance, integrating nature-based activities into a multi-regulatory governance system for nature-based solutions. The floor is yours, Eric.
Thank you very much, Nathalie, for the kind introduction, and thanks very much to the organizers for inviting me to give a talk here. Let me see. I'll straight away go to the first slide. Many of the previous speakers have already mentioned laws, national laws, international laws, policies. So I'm very thankful for that, because I will try to touch upon those who are mentioned before. And Ralph already mentioned the Sustainable Development Goals. And I use this picture to point out probably the main problem that we have in especially international law, and therefore also that trickles down to national law, which is between Goal 13 on climate action and Goal 14 on life below water, both on the lower left corner of this diagram on the right. What is the problem? So the Paris Agreement urges us to stay within that famous 1.5 degree in the 21st century rise of temperature. I heard from the scientists that most of the IPCC models, most of the calculations actually include negative emissions in order to reach that 1.5 degree goal. Some scientists told me that that's actually, if we want to reach that and we want to do that on land, then we need to plant trees on the subcontinent of India twice over, full with trees. So it's maybe not very likely that we reach that. So we need the ocean. We need the ocean to store greenhouse gases, mainly carbon. If we want to do that, we have one big problem, namely with Goal 14. Goal 14 prohibits us, more or less, of putting stuff in the ocean. Anything you would put in the ocean that could potentially hurt the ocean would namely be pollution. So this is the main problem. Climate change regime, the legal regime, would ask us, please put carbon in the ocean, very much simplified, whereas the nature protection law and the law of the sea would say, well, if you put carbon in the ocean, there will most likely be pollution. So what is the balance that we have to seek here? That's the first problem I'm going to talk about. Then a little bit about law at different levels. Depends also where in the ocean you are, which law is applicable. The law at different levels, international, regional, national, local, both enables mitigation as well as adaptation. And in the end, I will try to say something quickly about a potential duty to ecologically restore marine areas. This is an overview of how the law of the sea looks. Forget about the yellow small print, mainly the red one at the top is important. Presumably, we are all on land at the moment, and measured from the low water baseline, the first maritime zone starts. This is the Territorial Sea, and in this Territorial Sea, the coastal state has full sovereignty over any activities. This means that if we have blue carbon activities, often within those first 12 nautical miles, that is fully under the jurisdiction of the coastal state. The only exception to this full sovereignty, or the most important exception, is that every ship, so regardless of the flag it flies, has the right of innocent passage. And this might become important if we take Ralph's example of hitting a whale by a ship, for example. To what extent can the coastal state actually say you should take another route because there might be whales here? The next big zone, we skip the contiguous zone, we go to the exclusive economic zone. In this exclusive economic zone, the coastal state has sovereign rights over its natural resources. And this means that for most blue carbon activities, or nature-based solutions, the coastal state will also have sovereign rights. Then when we talk about the high seas, and this is where Lisa Levin started with, then we are talking about a regime where we have no national jurisdiction. And Jason Hall Spencer also mentioned that already, talking about at the moment, currently negotiated treaty on biological diversity in areas beyond national jurisdiction, the BBNJ. So the main message from this diagram is that whatever activity is taking place on the ocean, always be aware where it actually takes place in order to see who can regulate it. So if you are beyond national jurisdiction, many of the things that were mentioned, fisheries, for example, this happens through the fisheries, they're regulated through regional fisheries management organizations. We have the BBNJ treaty, we have deep seabed mining, currently negotiating a mining code. And all these agreements do take into account carbon to a certain extent, but not very much. So it's not their main thing to regulate climate change. They are focusing either on fisheries, they are focusing on mining, they are focusing on biodiversity protection, and not necessarily mainly on climate. It might be secondarily. If we talk about oil and gas extraction, that takes mainly place in the exclusive economic zone, and then the coastal state has full sovereignty over that because it regards natural resources. So coming back to the marine pollution issue, this is the, wait a second. This is the definition of marine pollution as mentioned in the 1982 United Nations Convention on the Law of the Sea. This is 40 years old, but a pretty broad definition, and I want to quickly point out some main points here. So marine pollution is the introduction by man, remember 4 decades old, not gendered yet, also women can pollute the ocean, directly or indirectly, of substances or energy into the marine environment, including estuaries, which results or is likely to result. And that is an important part. So we don't have to be sure that it will result in deleterious effects. Even if it's likely to result, this might already constitute pollution. Deleterious effects as harm to living resources and marine life, hazards to human health, hindrance to marine activities, including fishing and other legitimate uses of the sea, impairment of quality for use of seawater, and reduction of amenities. So carbon would also fit under this definition, and in some cases, therefore, be marine pollution. But what does the United Nations Framework Convention on Climate Change say about that? In its Article 4, it mentions that parties shall promote the conservation and enhancement as appropriate of sinks, including the ocean, and reservoirs of greenhouse gases. And there is actually an exception to what constitutes marine pollution, or more specifically dumping, in the Law of the Sea Convention as well. Placement of matter for a purpose other than the mere disposal thereof, provided that such placement is not contrary to the aims of the convention. So then we need to see, and this is mainly the case when we talk about negative emissions technologies or climate intervention, geoengineering, however you want to call it, is carbon uptake by the ocean a placement of matter for a purpose other than the mere disposal thereof? And that question can be answered per technology, and we have not found the definitive answer yet. So what are the general considerations then when we talk about nature-based solutions for climate change? Although it is not specifically regulated, like I said already, in international law, there are some international norms that we have to take into account. Generally, there is in international law a prohibition of transboundary significant harm. So whatever we do might not harm other maritime zones, be that of other states or be that beyond national jurisdiction. There's also what we call the so-called precautionary approach, and this has three main elements. There must be a threat of harm. There is uncertainty, but action has to be taken. So mainly that there is scientific uncertainty about something, about the harm that it can do. For example, if we are uncertain about that, that should not prevent us from taking action. And this might become important when we talk about what is pollution and what's not, and does carbon qualify as pollution in the marine environment. If we take actions proactively, we will have to do under most international rules as well as national rules, an environmental impact assessment, what the consequences are going to be for the environment. What is another main problem when we talk about carbon uptake of the ocean? It is mostly not considered that there is an interaction between the ocean and the atmosphere. And carbon uptake by the ocean is, of course, a prime example of this. Policymakers mainly look at either the ocean or the atmosphere, and not much at the exchange between those two. Article 4 of the UNFCCC on the promotion of enhancing sinks might be one of the exceptions, but also that is not explicit. By the way, the picture on the right, I was last week kayaking on the Pacific coast of Guatemala, and my wife was so kind to take her phone with her and take some pictures of the mangroves there. And the picture here on the right is also showing you mangroves. If I have to believe the guide, this is young mangroves planted in the last 5 years, and it was actually a protected area. And this is one example of how nations can do this. It is a protection area. That means there's no absolute prohibition of deforestation, so you can still use the mangrove wood, but you would have to replant something. And this is where you see an example on the right-hand side from last week. So how are we going to solve this problem legally? There's always two options for a new legal problem. It either, and then we can look at how we're going to solve that problem. You might either fit it under current law, or you develop new law. And for carbon, we are doing both. So we try to fit marine carbon uptake through nature-based solutions in current frameworks, and this is deep seabed mining, this is fisheries, oil and gas extraction, and we also develop new laws, for example, the BBNJ Treaty. Another thing that is much less known in international law is that we don't always need written law. We also have something like customary international law. This is the simple practice of states. And I could imagine that in the future, if many countries in their nationally determined contributions write in that they actually have used nature-based solutions in the ocean for carbon uptake. This might become a prime example for other countries as well. So, in a nutshell, if we want to intervene and we want to enhance the ocean sink, and this slide is both valuable for nature-based solutions as well as technological solutions, activities are mainly allowed unless they are forbidden. So if we decide that carbon uptake is not forbidden under international law, it is allowed. There's no general prohibition of carbon uptake by the ocean. There's no treaty as such, like I mentioned already, but existing regulation does affect climate intervention. And then as a note, what we also have to take into account is that the regulation differs for just doing research on carbon uptake of the ocean. So we can see how much carbon can be taken up and so on and so on and so on. That is a different regulatory framework as for large-scale implementation. And I would argue that we first of all need to have a legal framework in order to enable us to do the research on how this can be done. And only then we should think about a regulatory framework for the large-scale implementation of the outcomes of this research. And then my last slide, is there then a duty to restore? Because the main message I think from all the previous talks is as well, we need to protect. And I would argue that that is not the case yet, not under customary international law, nor under the conventional law. There's no general duty to restore ecosystems. And I gave the mangrove example already. However, if we say, and we follow the Paris Agreement saying well below 2 degrees, or as implemented by the IPCC, 1.5 degrees, max of a rise in temperature in the 21st century, then I think that it might be only possible to do that also with nature-based solutions involved. And this might then actually trickle down to a duty to restore ecosystems. And this comes mainly down in the future. This is not the case yet, but in the future there might be such a duty to restore. Maybe morally that duty is already there, and it could then later on translate into a regulatory duty to protect biodiversity and therewith also enhance the ocean as a sink. Thank you very much.
Thank you, Eric, for this excellent presentation. I don't know if we have questions from the floor. I think we had one by Maria Paz, but I see in the chat that Sonia has already responded. Any question from the floor? You can ask your questions in the Q&A section if you want. Well. I wanted to thank my colleagues of the UN Decade for the ocean, for the opportunity to have this session as a satellite activity in the Safe Ocean Laboratory. And I would like to direct my deepest thanks to the Mary Foundation and the Monaco Scientific Center for this fruitful collaboration. And of course, to the wonderful panelists for their excellent presentations. Thank you, Lisa Levin, Jason, Hal Spencer, Lars Seaman, Sonia Espanol Jimenez, also Ralph Chani and Eric Van Doorn for your time and presentations. And I don't know if we don't have more presentations. I just want to say that the outcomes of this workshop, I'm sharing the screen, will be developed in the UN conference in Lisbon, hopefully next June. And we keep all in touch to know what is going to go on. Thank you. Oh, wait, I see some questions. Let me see. Yeah, there is a question for Eric. How long would it take to get a legal framework to restore?
Yes, that is a very good question, to which I don't have an answer in years. In the end, if there would be a legal duty to restore, this all depends on an international level on if states would like such a duty to restore to be there. If this is going to be in conventional law, we need to write it down somewhere, right? Or we need to implement it through a conference of the parties for example, the next one, COP27, under the UNFCCC, or maybe even better, under the Convention on Biological Diversity, which also has a COP planned later this year in China, I think. And then they would adopt a resolution and say, well, there is now such a legal duty to restore. I think that the implications of such a legal duty would probably encounter some protest by certain countries. And that therefore it might not go through. The other option, like I said, is customary international law, and that takes very long. If customary international law goes fast, it's like 25 years or something. So normally it takes much longer, way too long. But that should not, this sounds very pessimistic, but that should not prevent states from already doing this, right? And on another level, Ralph gave already a very nice example from the legal rights of nature. More and more states are doing this, right? So why not, should states not write into their nationally determined contributions saying, we implement the Paris Agreement as saying implicitly there is a duty to restore. I think this has a very scientific basis. I mean, even if you look only at the David Attenborough Netflix documentary, it would already say biological diversity is the key to everything. If you look at the planetary boundaries framework from Johan Rockström and colleagues, they more or less say, at least that's my interpretation of it, of all planetary boundaries, biological diversity is the critical one that might connect everything. So if we keep on doing this, then this might put pressure on states to actually say, we have a duty to restore. And even if it's such a small example, like I showed from Guatemala last week, you cannot use mangroves and you can only use them if you replant, right? So if you restore ecosystems. I live in Germany myself. We cannot plant mangroves here, but why not do seagrass then, right? So there is, I think this is very much, if it doesn't work top down, we should do it bottom up. And all of my answer is not very legal because it's not law yet, but it could translate into a law in the future. How long it's going to take, I don't know. But the more pressure we put on governments, the earlier it could happen.
Thank you, Eric. I have a follow-up question from Sheila. Given that UNCLOS is not very strictly enforced, how do we make sure that this possible legal duty to restore is implemented?
Good question again. Indeed, the Law of the Sea Convention is widely ratified, right? There's 168 parties, and many of the main states that are not a party to it, for example, the United States, for example, Israel, for example, Turkey, do that only for specific reasons. So Turkey does it, for example, because they don't agree with the regime on straits, which would be disadvantage for the Bosporus. The United States doesn't do it for deep seabed mining. They, however, consider all the other rules in the Law of the Sea Convention as customary international law. And this might therefore be binding upon them as well. The main duty to protect and preserve the marine environment, if you want to read about it, is in Article 192 in the Law of the Sea Convention. And this is 40 years old and was then fairly progressive, and probably still is. And it is, then there follow exceptions, right? But you can still use your natural resources in the way that you want and so on. But it has progressed. The implementation is fully on the level of states. Right? So there's no international enforcement. There is a compulsory dispute settlement mechanism, but we've seen how that works when it involves big states like in the South China Sea. It doesn't work. So under small states, it does work, but so that implementation comes fully in the states itself. And then it's up to the states in order to do that, yes or no. And this can be done in two ways mainly, and then I'll stop talking and Ralph can add to what I was saying. In some countries, they call these monist countries, international law directly becomes part of national law. The Netherlands is an example. In most countries, however, Germany is an example of this. They have a dualist system. So there you need a national law to implement an international law. This gives it more flexibility, and you could also therefore adopt it stricter. So bottom line, states is who should implement it, and they might adopt stricter laws than the international law of the sea.
Eric, I have a question for you. So in my scenario, I say, why can't the government say, if you hit a whale, just because we're focusing on whales, in my territorial waters, there's a penalty, and the penalty is, some kind of dollar amount. Is there something that would stop a state from being able to say something like that?
In my personal opinion, there is not, because you can actually, and this is regulated in Article 17, 18, 19 of the Law of the Sea Convention, there are exceptions for innocent passage, right? There are certain things you can regulate. And in the past, there has been already, for Norway did this, we don't want oil tankers so close to our coast, so please go a little bit further out. So you can move shipping lanes because of nature protection. There are precedents for this. So I don't see why there should not be such a case. Worst case scenario, we have let's say a Panamanian vessel, because by far most ships are flagged under a Panamanian flag, that goes through the Gulf of Corcovado. Nicely, it's right next door, right? So that, Costa Rica would say, no, you are actually supposed to have pay 2 million because you hit this whale. Panama could protest and then say, no, we have the right of innocent passage, and the likelihood of us hitting a whale was so small, you could not have moved us to another area. That was illegal. Then it comes to court, and then we don't know what the court is going to say, right? So then it is always in law weighing two principles. At the one hand, nature protection, subsidiarily now also climate protection, actually, against trade, the simple right of states to have innocent passage. I think that a detour, as you said, Ralph, would be the least evil. And if I would be the judge, I would say, no, Costa Rica was fully entitled to do so. But we cannot be 100% sure that the judge actually will decide such a thing.
Right. But all we need, I mean, the point that I was making is, if we get the states to move, the markets will move. Because what people don't understand, they always ask me this question: you provide a value. I said, it's just the value. But if you want the markets have to believe that this is an asset or a capital. You can put it on your balance sheet. And to put something on your balance sheet, it's not only it has to be valuable, it has to be codified in the law. Mm-hmm. Because once it's codified in the law, it becomes visible on the balance sheet. And at that point, the market say, okay, I can insure it, I can provide services. So I was trying to figure out what is the best way that a government, if we're really serious about this, how we change the behavior of, because that's what we're after. We're trying to change people's behavior to be more, kinder towards nature and be, more observant. And that would be one way, which is the government takes a position. You hurt my whale, or basically, let's forget the whales for a minute. I mean, we had Jason was talking about Shell and all. What if you have a spill, an oil spill, and now it destroys the mangroves you're talking about? But let's say I come to your country and I value the mangroves at $2 billion. And now you are selling contracts, carbon offset contracts in the market for $2 billion. Shell now, whatever oil company, let's not, okay, has an accident and the oil, all the way down destroys the mangroves. You now have a legal, you now know exactly what the damage is. You're being deprived of a revenue of $2 billion. It's a game changer. You don't have to guess anymore what should be the economic penalty, because you are being deprived of future revenue of $2 billion.
Yeah, there's mainly three legal aspects to what you just said, Ralph, and that come to mind quickly. So first of all, if Costa Rica wants to impose such a penalty and they want international support for that, which makes it more likely for an international judge in that fictional case between Panama and Costa Rica to decide in their favor, put pressure on the International Maritime Organization. That is the international organization when it comes to shipping. And they could, for example, say, okay, there's a precedent, we allow moving of shipping lane for whales. If you have that precedent by an international organization, which works actually really well, considering all impediments of international law, then you would have a support for that. Second part, what you said about the oil, and which Jason already mentioned in Nigeria, another part of this is human rights that come into play, right? So there have been cases, many cases actually, before national, regional, and international courts, even a case in the United States, because of the pollution and in Nigeria by a British-Dutch company, namely Shell. The United States has very far-reaching laws when it goes to that, the Kiobel case. But the more interesting case is the Ogoniland case before the African Court of Human Rights, which actually said there is a human right to a clean environment. Right? So they actually interpret this case, okay, you cannot do oil pollution because it not only hurts the environment, with hurting the environment, it also hurts people. I give a very simplified summary of the case. So that's the human rights equivalent. Another human rights equivalent, which is coming up more and more, especially after Minor Oposa case before the Philippines Supreme Court in the 90s already, where some miners and their parents actually sued the national government for handing out contracts for deforestation. The Philippines Supreme Court said there is a right of future generations. And if we implement that, that is not a right on the international level yet, but more and more states start implementing it, where it actually says we have future generations do have rights to certain nature. We saw that in Germany, where the German Constitutional Court actually said Germany does not do enough with its national climate law in order to protect the rights of future generations. The Dutch Urgenda case also did not focus on future generations, but on human rights itself, the European Convention on Human Rights. So this human rights dimension starts to come into play more and more and more when we talk about these climate change cases. And I think that's also another legal avenue that more and more states could go. And the Urgenda case, the German case from last year, could set into motion a whole range of national law cases in other states where cases decide these kind of things. Sorry to give such extensive answers, but never let a lawyer talk, right? He only has words, so that's the only thing he's going to use.
Thank you, Eric. Thank you. I have a question from Sheila to Jason. How will climate change and heat waves impact the restoration of seagrass in the UK?
Well, we're fortunate that seagrass it's got quite a large biogeographic range. Okay, so it lives quite happily down in the Algarve, the species we have in the UK, and spreads all the way up into the north of Norway. So climate change is expected the warming isn't expected to harm this seagrass species. And on top of that, the extra CO2 in the water from ocean acidification actually boosts its growth and increases the amount of carbon it stores below the seabed. So it's one of these organisms that's likely to gain, in fact, from increased CO2. And that's just as well because we need it to help take carbon dioxide out of the water. Does that answer the question?
Yeah. I don't see other questions. Maybe, yes, one for Ralph. How can we ensure that whomever owns the whales do not exploit it?
You cannot own a whale. This is not about owning a whale. By the way, we are already exploiting the whales. We're killing them with impunity. I mean, I always hear that, are you putting a price on whale? I said, no, you put a price on whale. It's zero. I'm just telling you that the price of the services of a whale is not zero. The current system tells you can kill a whale with impunity. And what the work that we're doing shows you is that the value of a living whale to society in terms of the ecosystem services is incredibly valuable. Now, when we talk about the sale of the carbon comes from basically allowing the whale to frolic freely. If the whale happens to be in the waters of Chile, let's say because there's some species of whales that don't necessarily migrate, then you can sell their carbon services, but you're not selling the whale, nor can you put them in a zoo or in an aquarium or anything of the sort. So in fact, this paradigm frees nature because you can only get value from it when nature is alive and thriving. So it's a value of a regenerative nature, not of an extractive nature. You're not extracting stuff from, you're not selling dead fish, you're not selling a dead whale for $30,000 or a tusk of a dead elephant for the same amount.
Okay, thank you. Maybe we can close the session, but before I would like to give the floor to each of you, maybe for 2 minutes to say the ending words or sentence. We can start by maybe Jason.
I was just answering a question from Sheila, so I missed yours. What was it?
Oh, yeah, I was saying that we can say some words to conclude, and I'm going to each of you to say maybe one sentence or two for the end of the session.
Okay, well, I'm very happy that the conversation has moved on from just coastal vegetated habitats to including all marine life in the whole when it comes to helping us keep the ocean safe for human people at the coast, and we all need the wildlife in the sea. So I'm glad it's got to this stage. Thank you.
Thank you. Maybe now, Lars, would you like to add some words?
Well, I would like to complete Jason's point that, in fact, I think for the open ocean, we can discuss what about things that you have been dealing with in the recent past, because we are, I think, for the open ocean, we are just beginning. So there is a lot to understand from what you have been doing.
Okay, thank you. Sonia, I saw that you replied in the chat to different questions. Would you like to add maybe some words for the end?
Okay, thank you. Well, I am very happy to see how we are making progress in the conservation of the oceans and of whales, of course, where we need not only science, but also change in politics and in the current economic model. So I think that we are in a very good progress, but we need to do more. Yes.
Thank you, Sonia. And Ralph, some words to conclude?
Sure. I would like to just build on what Lars was saying, is the open ocean, as I learned from him and others at the Monaco meeting that you held, is that the open ocean is the orphan. And the orphan, and yet it's the open ocean is looking after all of us, at least in carbon sequestration, is doing tremendous amount on behalf of humanity. And if we don't do something about it, we're going to basically hurt the open ocean, thereby also hurting humanity in ways that we can't recuperate from. So we need to, as Jason is saying, we need to move away just from talking about the sort of coastal blue carbon to looking at the system as a whole, the cetaceans and the vegetation, the flora and the fauna, in other words, biodiversity. Thank you.
Thank you, Ralph. And Eric, last words.
Yeah, thank you, Natalie. I've said this already, I think, but biodiversity protection is probably the main thing when we talk about this topic. And this is an open door and it's preaching to the choir here. But if I focus on the legal solutions, politicians have been drawing lines in the ocean since forever, and they normally disregard any ecosystem, right? So they don't make any sense from an ecosystem perspective. And that is something we have to deal with, and we have to find solutions for. And for example, in fisheries law, this has been done, saying now that there is a duty to have compatibility between fishing laws within the exclusive economic zones, so under national jurisdiction, with those beyond national jurisdiction on the high seas, or what natural scientists mostly call the open ocean. I think we should do something similar when it comes to nature-based solutions in the ocean. We should make sure that up to 200 nautical miles, where the coastal state has sovereign rights over nature, we should make sure that that is compatible with what is happening beyond those 200 nautical miles, because those 200 nautical miles don't mean anything from a natural perspective. And I think that the chance that we now have with the BBNJ treaty that was already mentioned by Jason is a very good opportunity to bring these protection mechanisms in line with each other. And lawyers normally are very conservative, but to end on a positive note, I think that it's possible. And we have seen precedents for doing so. So why not when it comes to carbon uptake of the ocean?
Thank you all the speakers, and also the audience. Thank you for everybody for being here today. I think it was important to speak about the ocean and how to conserve it, why it is important to conserve it. And I hope to see you all again for next steps. Bye-bye.